Okay, so I have inserted a map of currents. So you can see the major currents in this map. And then I have inserted also another one. Okay, so later on we will study about the circulation of currents. But for now, we will study some of the known currents. Okay, so this is from the ocean passages for the world. So you can see here in the Atlantic, the Gulf Stream, first the Florida current, and then it continues as Gulf Stream, and then it is connected to the North Atlantic current, and then it will go to the coast of Ireland and also in Norway. And then some of the Gulf Stream will go downwards and connects to the Canary current. As you can see, this is the circulation of uh, currents in the northern hemisphere. So it is more likely clockwise. And in the southern hemisphere, it is counterclockwise. So you can see the south equatorial current. It will some of it will go down, some of it will connect with the Guyana current, and then some of it will connect to the Brazilian current, but it also circulates to connect to the Southern Ocean current, and then it will connect to the Benguela current. So there is also a circulation which is counterclockwise in the Southern Hemisphere. The same with the Pacific. Okay, so in the Pacific, you have the Japan current, the Kuroshio, which is connected to the North Pacific current. And then upon reaching the near the coast of America, some of it will go down to connect to the California current, and some of it will go upwards to connect to the Alaska current. And then the California current will connect to the North Equatorial current, and then connects to this current in here in the coast of the Philippines. And then it will again connect to the Kuroshio. So it is also a clockwise direction. Okay, so in the Southern Pacific, the South Equatorial current will most likely go to the coast of Australia. But some of it will also go down, but not so much now. And this one will connect to the Southern Ocean current, and then it will connect also to the Peru current or the Humboldt current. So there is also a circulation which is counterclockwise in the southern hemisphere. In the Indian Ocean, in the North Indian Ocean, it is affected by the monsoon. So it depends upon the months. But in the southern part, it is also circulating the same as the southern hemisphere of Atlantic and Pacific, which is counterclockwise. So the South Equatorial current will go downwards, connect to the South Indian Ocean current, and then connect to the West Australian current, which most of the West Australian current will travel along the coast of Australia. And then this one will connect also to the South Equatorial Current. So there is also a counterclockwise direction or circulation. Okay, let's start with gyres. So gyre is a circular pattern of currents in an ocean basin. We have the North Pacific gyre or North Pacific current, South Pacific gyre, North Atlantic, South Atlantic, and South Indian Ocean gyre or current. We have also the Beaufort gyre, Ross gyre, and Weddell gyre. So the last three is a part of the 20 that you will research later on. So let's go back to the map. Okay, so as you can see, the gyres are in a circular pattern. So for example, the Gulf Stream, which is connected to the North Atlantic Current, is going in a cycle that is clockwise. No? And the North Atlantic Current is connected to the Canary Current and to the North Equatorial Current, and then go back to the Florida Current and Gulf Stream. So paikot lang siya, ano, which is clockwise pala. And in the southern hemisphere, it is counterclockwise. So as you can see, the South Atlantic current and also the South Equatorial current. And in the Indian Ocean, we have also the South Equatorial Current and the South Indian Ocean currents, which forms a counterclockwise because it is already in the southern hemisphere. And then in the Pacific, you have also the North Pacific Current and the North Equatorial Current forming a clockwise direction. And in the South Pacific, there is also the South Equatorial Current connected to the South Pacific and to the Southern Ocean Current, forming a circular motion and connected to the Peru Current, which flows along the coast of South America. Okay, so the Beaufort Gyre, Ross Gyre, and Weddell Gyre, um, one of these, if not all, is located in the Arctic. So you have to research later on. And then we have other currents, which is the Tsushima Current, Alaska, Somali, Genya Current in Africa, the Canary Current, which is used by Christopher Columbus to discover America. So it is not intentional that he will go there, but the vessel is brought by the current and the winds, which is the same clockwise direction in the northern hemisphere. And we have the Guyana currents or current, and then the Florida current, and then West Greenland current and Erminger current. So later we will check. Okay. So this is the Canary Current. I will enlarge. Okay, so this is the Canary Current. So Christopher Columbus coming from this part, sailing in this part, and then he discovered America. No? So because of the circular uh, direction of the current. And then we have the Guyana current here, which is an effect of the south equatorial current that is divided. The other one is going to the Brazil current and the other one is to the Guyana current. And then going back to the Florida, which is driving the Gulf Stream. Okay, we have also the Guinea current here in the Gulf of Guinea in Africa. And this is a dangerous sea area today because of the Nigerian pirates. Okay, we have also the Somali current, also a dangerous area because of the Somali pirates. And this is a very strong current, reaching up to 7 knots. I have passed many times here between the Socotra Island and Somali, this cape in Somalia. Before, when I was cadet, there are no Somalian pirates operating yet. Wala pa, no? So normally we are coming from Greece or in Europe, and then we will pass Suez Canal, no? Yung na-block ng the latest na-block siya ng ano tawag dito, container, no? Pero nakalabas na yata for how many days, no? So malaki ang babayaran ng container vessel because of they cannot operate or other vessels cannot pass. Siyempre, that is producing revenue for the for the government of Egypt. So malaki, no? Malaki. And also, malaking nawala doon sa mga tao doon because that is a Marlboro country. No? Lahat ng kilos dyan, Marlboro. Kaya pag dumaan ka dyan, you must have a Marlboro. No? So passing there, Red Sea, and then we go in the Gulf of Aden, and then we go to the Richards Bay in South Africa. So we are passing here in Somalia, and there is a very strong current in this area. No? Pero baka hindi nyo na masubukan yan because nobody is going in these areas. No? So if you are going there, lumalayo pa ng gusto in the middle and then coming back. So nobody is passing in Somalia anymore. Merong mga nag-attempt pero normally napipirata. So Alaska is of course in the Gulf of Alaska. So this is actually a continuation of the North Pacific Current or the Crucio. No? And then before reaching the coast of North America, some of the current will connect to the California current. And then some will go upwards, which will form the Alaska current. If you notice also, above the main circulation, which is The main circulation is composed of the North Pacific and the North Equatorial Current. Above will have a counterclockwise direction. Hindi lang siya dominant. It is only not dominant as in the middle. So if you notice, there is a counterclockwise. The same in the Atlantic. So if we go to the Atlantic, the main circulation is clockwise, but as the Gulf Stream connected to the North Atlantic is going up and then connect to the Norway current, this is the Norway current, passing along Ireland and along the coast of Norway. So this is Norway, and changing the climate there, preventing some formation of ice. That's why they say New York is um, colder than the Norway because of this Gulf Stream. So before reaching the UK, some of the current will go upwards, which forms the Irminger current. And if you notice, there is a counterclockwise circulation here because it connects also to the East Greenland current and then goes back. So on the other side of Greenland is the West Greenland current. So Tsushima current is in Japan. So this is actually between Korea and Japan, Tsushima current, and this is going upwards. Of course, the Kuroshio is just like the Gulf Stream. Okay, so we have also the Davidson current. This is what I was explaining during the last meeting, but I forgot the name. No? Sabi ko brand of the motorcycle eh. So this is yung nga, Harley Davidson. No? So Davidson current is along the coast of California, which is located between the California current and the coast of California. So the California current is going down towards the equator. So this is a cold current. And the Davidson current is a counter current going upwards. But most of the time, the Davidson current is located below the sea level, around the 200 meters. Eh, hindi maramdaman ng barko. No? But there are times that it is located in the surface. So pwede siyang gamitin for navigation because of that. So you can use it for navigation during times like, I think it was November. So this is also a part of your research. So we will study later after you finish the research. And we have the Baffin Island current located in the western side of Baffin Bay. The East Iceland current between Greenland and Iceland, and the Norwegian currents, which I've explained already, also known as the Norway coastal current. And then we have the Antilles current, which flows at Caribbean island chains. The Caribbean island chains is the one dividing the Caribbean Sea and the Atlantic Ocean. So in between those islands, there is a current which is called the Antilles current. And then inside the Caribbean Sea, we have the Caribbean current, which is flowing to the Gulf of Mexico. So we can check that one. Okay, so these are the Caribbean island chain. So somewhere here you can find the Antilles current. And if we continue the Guyana current, you can see here in the Caribbean Sea, this is the Caribbean current going inside the Gulf of Mexico. Okay, we have also the West Spitsbergen current, which is located west of Spitsbergen in the Arctic. And then Leeuwen current along the coast of southwest Australia. Of course, we have also in our country the Mindanao current along the eastward side of Mindanao. And then we have the Indonesian through flow along Indonesia from the Pacific Ocean to the Indian Ocean. So this is passing in those Indonesian islands that is dividing the Pacific and the Indian Ocean. Okay. So sa the Indonesian through flow is not so not indicated here, no? But actually it is coming from the Pacific here and going to this part of Indonesia, and then these are the islands. No? So this is called the Indonesian through flow, passing to towards these islands. So this is the Indian Ocean and this is the Pacific. So it is flowing through the islands of Indonesia, especially these islands, yung division between the Pacific and the Indian Ocean. Okay, oceanic circulation in the North Atlantic. Wait, dalawang da. Okay, the cool south-going currents on the east flank of the mid-ocean anticyclone merge into the wide band of westbound current on the equatorial side, and most of this turns northward on reaching the Caribbean to form the warm Gulf Stream, while a small portion turns east to help form the Caribbean countercurrent on the northern flank of the anticyclone. The Gulf Stream fans out into the North Atlantic drift current, part of which eventually turns southeast to complete the circulation, while the remainder swings northeast as far as the north coast of Norway. The flow of currents from and around the Arctic is a little complicated, as can be seen from the chart. Okay, so the North Equatorial Current will go westward and then connects to the Gulf Stream. But first, with the Florida Current. So it will go again to the North Atlantic Current, and some of it will go towards southeast and connect with the Canary Current to complete the circulation. And then some of the Gulf Stream or the North Atlantic Current will go upwards and connect to the Norwegian Current. But in the Arctic, it is not clear, although it is somewhat counterclockwise. But it is not as clear as with the North Equatorial Current and the Gulf Stream. So the same in the Pacific. ocean. There is a there is a clockwise direction in the North Pacific and counterclockwise in the South Pacific. Okay, North Pacific, in most of this ocean, the circulation is very similar to that of the North Atlantic. A cool south-going current on the east side of the anticyclone, a wide equatorial current flowing west on the south flank, and the warm north-going Kuroshio in the west, similar to the Gulf Stream, while there is an east-going current on the north side on the extreme west of this ocean. However, in the area of the China Sea, the current flows northeast or southwest in accordance with the monsoons. As in the North Atlantic, there is a fairly diverse pattern of currents in the Arctic area. So the same as in the Indian Ocean, there is a monsoon in the south on the China Sea and also in the Indian Ocean. Okay, in the North Indian Ocean, the surface currents here are governed entirely by the monsoons. So that in the open ocean, they flow eastward during summer, that is called southwest monsoon, and westwards during the winter, that is called northeast monsoon or during northeast monsoon. In the extreme southern part of this ocean, close to the equator, the east-going equatorial countercurrent flows eastward throughout the year. And close to the East African coastline, there is a northerly current in summer and a southerly one in winter. That is called the East African Coast Current, sometimes called the Somali Current or the Somali Current. The summer current here may have a rate as high as 7 knots. Okay, so this is northeast monsoon. So here in this part, northern Indian Ocean, it is affected by the monsoon. The direction of the current is affected by the monsoon. So if you are going to pass here, you must know the uh, when is the southeast and the northeast monsoon. But it is indicated in your chart normally. But in the southern Indian Ocean, there is, of course, a circulation, which is in the southern hemisphere, it is counterclockwise. So the south equatorial current always go westward, including also the north equatorial current. You can see in that Atlantic and in the Pacific. So westward pa rin. And then it will connect with the South Indian Ocean current to form a circular motion or direction, which is found in the southern hemisphere. Okay, in the southern hemisphere, the surface currents of the South Atlantic, South Pacific, and South Indian Ocean follow, in general, a regular pattern of anti-clockwise or counterclockwise circulation round the periphery of the permanent anticyclone in each ocean. Each of these oceans has on its eastern side a relatively cold north-going current and a warmish south-going current on its western side. In each, there is fairly steady west-going equatorial current and countercurrent. But it is only in the South Indian Ocean that the equatorial current is found south of the equator. The outstanding feature of the currents in this hemisphere is in the southern part of each ocean, which combine to form what is called the Southern Ocean, where there is a very wide band of permanent east-going current encircling the world or encircling also Antarctica. So let's go back to the chart, map. Okay, so southern hemisphere, it is said that the circulation is anti-clockwise or counterclockwise. And if you notice the countercurrent or the equatorial countercurrent, so here the equatorial countercurrent, which is not indicated, is above the equator. So the equator is this line, 0 degrees. And it is only in the Indian Ocean that is the equatorial countercurrent is found south of the equator. So if you notice also in the Pacific, the equatorial countercurrent is north of the equator. So this is the equator and this is the countercurrent. So the southern ocean current is encircling the globe on this southern ocean, and that is around also the Antarctic. But if you notice these arrows, these are affected by the Coriolis effect. That is why some of them are going up. Okay, let us continue with the oceanic circulation. So in the Mediterranean, the currents there, the general circulation of the surface water is counterclockwise. It enters from the Atlantic as a surface current through the Strait of Gibraltar. Kasi wala naman siya ibang dadaanan, di ba? Because the Mediterranean is an enclosed area. And there is only a small opening which is less than 5 miles. Mga 2 miles lang nga yata yun. I guess. I forgot the distance there. No? Pero maiksi lang yun. Sigurado ako hindi abot yun ng 10 miles. So, the surface current will enter through the Strait of Gibraltar and flows thence along the North African coast. And then due to the high rate of evaporation throughout the Mediterranean, the salinity of the surface water gradually increases and it sinks. Hence, the outflow of the denser water through the Strait of Gibraltar to the Atlantic takes place below the surface inflow. So, sa ibabaw, going inside the Mediterranean, and sa ilalim ng tubig, it is going outside to the Atlantic. So, hindi sila nagkakasalubong. Yung isa sa ilalim, yung isa sa ibabaw. So I do not have a map for Mediterranean. But anyway, maybe you can research it. So this is the more dominant current flowing along the coast of North Africa. And then it will go back along the island of Sicily or along the Italian coast, the French coast, and also Spain. And then it will go back again to the Atlantic, but it will flow underneath the surface current because the surface current is coming inside from the Atlantic. Okay, wind drift current. The major current circulation of the oceans are wind drift currents. The wind circulating around the oceanic anticyclones in all oceans and the westerly wind circulation around Antarctica drive wind drift currents which circulate around the oceans, clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. These currents are modified by land masses to produce secondary currents. So because of the land mass, naghihiwalay yung main current and then it will produce secondary currents. And then the monsoon winds of the North Indian Ocean produce wind drift currents that reverse their circulation with the reversal of wind direction of the monsoons. Okay, the northeast monsoon is from November to January. In open waters, the current sets westward near the coast of the Arabian Sea. There is an anti-clockwise circulation. And in the north part of the Bay of Bengal, there is a clockwise circulation. Okay, let me show you. So this is not from November to January, because this is clockwise, the same. And this is the Bay of Bengal, clockwise direction. So it is said there that during this time or during the northeast monsoon in the Arabian Sea, there is an anti-clockwise circulation, which is not shown in the map. And then late northeast monsoon in February to April, the open waters, the flows remains westward. Near the equator, the westward flow declines and turns eastward. Magbabago na siya ng direction. Hihina and then magbabago. In the northern Arabian Sea, a clockwise gradient current circulation forms. The southwestward flow along the east coast of Africa declines and reverses direction by the end of the period. And then the southwest monsoon is from May to September. In open waters, the current sets eastward. Babaliktad na yung current, going eastward na. And then near the coast of the Arabian Sea and the Bay of Bengal, circulation is clockwise. The Somali current is particularly strong, reaching up to 7 knots south of Socotra. So yun ang sinasabi ko kanina, di ba? The Somali current, is a very strong current. And then we have also a transitional phase in October. The strength of the currents decreases as the wind pattern changes. Okay, gradient current, the causes. Gradients in the water surface may be caused by the water movement in response to wind or differences in density of adjacent water masses due to salinity or temperature differences. When a gradient has developed, water flows down the slope. This water flow is affected by the Coriolis force and deflected accordingly. So I believe the Coriolis force is already explained to you before, no? So this is the effect of the rotation of the Earth. Anyway, I have a video that I will show you later on. I will post in the LMS regarding the Coriolis force for you to remember. And then a current flowing perpendicular to the direction of the gradient results. So gradient is the change in the value of a quantity such as temperature, pressure, or concentration with change in a given variable and spatially per unit distance in a specified direction. That is according to the Merriam-Webster dictionary. Okay, trade winds in the Atlantic and the Pacific Oceans and the northeast monsoon and southeast trades in the Indian Ocean propel water westward against the bordering land masses. A raised water level results in on the western side of the ocean basin. A hydraulic gradient exists from the western side of these oceans toward the east. A narrow current flows downward or down the hydraulic gradient eastward between the westbound wind drift currents. Due to the low latitude, no Coriolis effect occurs and the current flow directly down the gradient. That is in the Pacific Ocean. And the Atlantic equatorial current varies seasonally in extent from a maximum westerly origin of 60 degrees west in September to a minimum of 20 degrees west in March due to the seasonal movement of pressure wind current systems. And the Indian Ocean equatorial current is absent during the southwest monsoon due to the northward current generated in the western North Indian Ocean preventing the development of the hydraulic gradient. So the southwest monsoon is from May to September. Okay, the Gulf Stream. The easterly trade winds of the equatorial Atlantic produce the north and south equatorial currents flowing westward. Part of the flow of the south equatorial current is diverted into the northern hemisphere by the South American landmass. A strong flow enters the Caribbean Sea, raising the level and producing a gradient flow into the Gulf of Mexico. The level here rises and the gradient results across the Florida Strait to the Atlantic. The water flows strongly eastward and northward through the strait as the Florida current and then forms the Gulf Stream. So na-explain ko na rin to kanina. No? Okay, so that is our lesson for today. Now you need to do the activity number 2. So research the following currents. You have 20 items, so 5 points each. And if you can pass today, maybe you can have a perfect grade. But if you will pass after the deadline, then I will deduct some points in your work. So, siyempre, hindi ko nabibigyan ng 5 points yun. Maka 4 points na lang. Okay, so screenshot this one. And then I will put also in our group chat and in the LMS for submission. So, okay, gentlemen, thank you for listening. That's it for today. So, just be busy with the activity. Okay, thank you for listening. I will end this meeting.